So recently I've been having a lot of fun playing with Lidar scans and combining them with 3D artwork. Now for those of you that don't know, Lidar is basically a kind of technology that lets you get distance data as well as other things. The actual word Lidar is a portmanteau of light and radar, but some people have other definitions for it as well, such as light detection and ranging or laser imaging detection and ranging. It really doesn't matter, it's all of these things in one. Now when talking about Lidar for 3D work, what we're basically saying is using Lidar data to construct 3D meshes based on the distance data that's returned to the piece of technology. And you can use specialized apps to take the data and turn them into 3D models, which you can then export and use them in any software you like. So recently I've been playing with the iPhone and with an app called Polycam. There are other apps available as well, but I haven't tried them yet. And the results have been quite impressive. Now I've always been interested in this idea of taking stuff from real life and using it in your own work because it adds this whole other dimension of realism, and it just generally adds details that you would never think about adding yourself because they're either too mundane or would take too much time to put together. But one of the reasons I've shied away from regular photogrammetry is because for me it's a bit too much of a time investment. There's also quite a lot of cleanup involved when doing photogrammetry scans, and Lidar is no different, but having the distance data there really makes an improvement to accuracy. So I'll show some footage on the screen now. Basically you just have the app open, you hold it up, and you can see a visualization of it trying to construct geometry around what the camera is looking at. And you can optionally choose to show or hide the color data as well. And this just proves that it is actually using distance data. Basically it uses the Lidar data to construct the mesh, and then the photo data to construct the textures that get wrapped around the mesh. So just by walking around at different angles and pointing your camera at different objects, rooms, environments, it will automatically construct the model for you. And in the case of the Polycam app, if you spend a little bit of money, you can export an unlimited number of scans. For example, you could export to an OBJ, email that to yourself, then open that up in Blender, and because the material file is also associated with it, it will auto-assign all the textures, so you can just open it up, render it in Eevee, and boom, your scan is there. Now if you have a semi-decent understanding of how to manipulate 3D objects and textures, you can then clean this up, use the environment for your own artwork, or even steal props from it. Now the whole idea of stealing props and items from the real world and using them in your artwork is not new to the community. In fact, I highly recommend you watch the World Building in Blender speech by Hubert on the Blender channel on YouTube, because this goes over a similar process that's only using 2D imagery, where if you take images, you can then essentially project them onto geometry, and then you can extrude areas, add whatever geometry you like, duplicate some areas, use extra images for more detail, and then you can basically construct props using the images not only as references, but also as sources of texture data. And then of course these props can be saved and added to a library and reused again in the future. Now with the Lidar scans this is interesting because you don't need multiple images. All you need to do is press record, have a look around the object, and then you can take it away. Now there are of course some limitations, namely the mesh resolution, because in the case of Polycam it seems that the mesh resolution is kind of tied to the world space. When you're processing the scans you do have some options for the voxel resolution where you can reduce it as far as possible, but even then it's still not viable for small props. So this is really more useful for doing actual environments rather than small items. Also there are issues where if you have an object, even if it is quite a large one, but it's perforated and it has holes in it, the algorithm has trouble interpreting where the geometry should be constructed around that object. So sometimes you might end up with strange texture data where objects should be. See here where I scanned this garden, the bench is kind of splayed out onto the floor. It doesn't exist, but a shadow of its former self has been merged into the texture data. But putting those inconsistencies aside, there's so much potential here for the real-time scanning of entire environments. Environments that you can then remix and reuse in whatever projects you like. So it's been really fun playing around. Now I've managed to create this UFO artwork that I'm calling Bad Parking, where I've basically taken my garden and crashed a UFO into it. Now you can tell from looking at this that it's a combination of the Lidar scan data and regular 3D models. And like I said at the beginning, with the scan data you get all these kind of mundane details that you would not have added otherwise. Like take the back fence for example, I'm never going to be bothered to make that manually. Sure, you could texture paint that if you had enough time, but for me personally my patience is very thin, so I like just being able to slap things together and make something pretty. Being able to have all these realistic mundane details helps you to really compose a scene in a very short amount of time. Now because data is data and it's all accessible in Blender, it doesn't mean that the style of your artwork needs to be strictly tied to the scan you've created. For example, because the texture data is attached to the materials, and the shader node system in Blender allows for all kinds of procedural effects, I can combine my ambient grunge node with the texture data and then procedurally add dirt to the scan. So you can start layering up all kinds of procedural effects on the data that you've imported. Now, of course, some cleanup is required when you import the scans. So for the geometry, you might find random bits of mesh sticking up out of nowhere where it hasn't resolved properly. If it's subtle, you could fix this just by using the sculpt mode and smoothing it out. If there's something extreme that's gone wrong, then you'll need to go into edit mode and manipulate the vertices manually. But you'll need to be careful when making new geometry, because the geometry that's already been created has generated UV data attached to it. So if you make new faces, they will not be appropriately mapped to the UV map. But of course, what you can do is generate geometry from the pre-existing geometry through things like loop cuts and using the knife tool. Say you had a round surface that didn't look quite right, you could use the knife tool to draw a line around it and then scale that down. So you're basically manipulating the shape of the scan. Now, of course, what's very useful here is proportional editing. So if you're in the edit mode and you press O on the keyboard, this will enable proportional editing. So if you start dragging vertices around, you can scroll on your mouse forwards and backwards to manipulate the threshold. So as you're moving the points, there's going to be a fall off where it affects other nearby vertices as well. Now, that's not just for moving, that's also for rotating and scaling. So it's incredibly useful if there's any areas where the distance isn't quite right or things have been blown out of proportion. You can kind of smoothly, manually move them back into place. So the other main issues come from the texture data. Sometimes, as I said, things will exist in the texture data that don't exist in the 3D geometry, or alternatively, because you scanned it in a slightly bad way and the texture data is only available from a skewed perspective from where your camera was looking, things may be a bit jagged and strange and really off proportion. This is where the texture painting mode in Blender is really useful, and especially the clone tool. Because with the clone tool, you can take pixel data from somewhere else on the textured object, and then paint that where things are inconsistent. So with some careful manual effort, you'll be able to resolve these inconsistencies and make it look a bit more realistic. Of course, things probably won't look perfect up close, but if your camera is in the right position, then you should be able to end up with a passable result. Now, another little technique I did in this specific artwork was take the tiles on the floor, use the knife tool to draw squares around where the tiles were, then assign these to a vertex group, and then once they were all cut out, I then extruded them upwards to give the ground some more depth. Now, this is useful because the mesh resolution from the Lidar scans isn't particularly high, so by going in yourself manually and adding these extra extruding details, that really helps to sell a sense of depth. Then if you have this data and you've fixed it up, then what you do from here is completely up to you. There's so much you can do with this, and there's so much potential for making 3D artwork, even for animations. I mentioned Hubert earlier because he's known for doing lots of this kind of stuff, but you should definitely check out his work because he's quite popular in this community, and he's definitely more from the side of visual effects and combining real-world data with 3D artistry. Now, of course, the elephant in the room is that trying out this LiDAR scanning technology and these apps with a mobile phone has quite a significant monetary barrier, because as I said, I've been trying this on the iPhone 12 Pro. There are, of course, other phones and devices with LiDAR scanners, but not every app is available for every device. So if you do want to try this technology out, then you should do some research beforehand. Otherwise, as I said, there's other very viable options like regular photogrammetry, so taking images of a 3D object at multiple angles and then reconstructing the geometry afterwards. There's tons of software to help with that. And alternatively, there's the camera projection or UV projection method outlined in the talk I mentioned, where you basically take simple images and construct objects from those. But overall, it's very fun to play with, and it can give you an entirely new perspective on generating 3D artwork. Now, this final blend file is available on Patreon under the $10 tier. And I also want to say a big thank you to everyone that's been purchasing the Modular Metals pack so far. It's the biggest pack for Blender I've made up until this point, which is naturally why it's the most expensive one. Okay, so hopefully you found this video interesting. Let me know if you've played around with LiDAR scanning, photogrammetry, or UV/camera projection from images. So thanks for watching, stay safe, and I will see you next time.